change the question a little bit. I don't want it to happen step by step. I want it all happen together. So first of all, it says the graph of G is obtained from the function with rule y equals to x squared. So I have x and y. So I want to know what I have. So I have x and y. That's the original function. Then it's by a translation of 3 units in the positive direction of x-axis. So x dash will equals to x plus 3. Okay, 3 units in the positive direction of x-axis. New x equals to original x plus 3. And translate 1 unit in the negative direction of y-axis. So y dash equals to y minus 1 in the negative direction. Then followed by a dilation of a factor half from the y-axis. What is changing? Everyone, what is changing? Dilation by factor half from y-axis. X. So I will change x times that by a half. So half of the original x value. And a reflection in the x-axis, what is changing? Reflection in the x-axis, what is changing? The y value. So I will times the y by -1. But, okay, calculation order must be the same as the transformation order. So you moving down first, you need to calculate y minus 1 first, and then times by -1. So you need the bracket there. Okay, you need the bracket around x plus 3 and y minus 1. Then follow a translation of 1 unit in the negative direction of y-axis. Then I will minus 1 again. Okay, this is times by -1. And then I'll subtract 1 because it's keep moving down by 1 unit. And a dilation from the x-axis of a factor a third. Okay, from the x-axis is changing y again. Okay, it's changing y again. So I will times by everything by a third. Okay, that's exactly the same order as what is happening here. Okay, so you need to follow exactly the same order. Okay, the next question we think about is what we have and what we want to achieve. We want to achieve x dash y dash. What we have is x and y. What I have, I will make that to be the subject. Therefore, I need to make x, y to be the subject. So x equals to 2x dash minus 3. This is easy to do. So rearrange it. X equals to 2x dash minus 3. Okay, y is a little bit complex. Let's do step by step. So I can see this is times 3y dash plus 1 equals to negative bracket y minus 1. I'll minus both sides. Minus 3y dash minus 1 equals to y minus 1. And this 1 and 1 can get cancelled. We have y equals to minus 3y dash. Okay, y equals to minus 3y dash, which is like a really simple expression in the end. And what we have is, well, we want to find the rule of g, which is the new function, resultant function. Therefore, I need to do substitution. Okay, first of all, according to the description, write out the equation, x dash y dash in terms of xy. And then rearrange it to make it xy to be the subject, because we have x and y. Then the next step will be substitute. Replace xy by x dash y dash. Then you can have the new function. So I have minus 3y dash equals to 2x dash minus 3 squared. So y dash equals to negative 103. Bracket 2x minus 3 squared. Okay, I want to do something well, it's more algebra. It's nothing really related to transformation. Can you see, like, this is not really the turning point form. The turning point form should have a single x in the bracket, like x minus h squared. Well, it's nothing wrong with this equation. I can leave it like this, but I'll prefer you can get the 2 out to make it, well, either expand it or you can make the 2 outside to make it look like a turning point form. Well, same as the turning point form. So how I can get out this 2? Well, it's not really necessary, but I really want to say, because we have a similar question later, we need to know how to get out this 2. So if we want to take this 2 outside, let's have a look. I'll write here. Y equals to negative a third. Okay, do not do anything yet. Let's take 2 as a common factor from the inside. I have x minus 3 over 2 and then squared. Okay, that's what we should do first. We take the 2 as a common factor, like we take common factor for those 2 terms. But don't forget, you still have the square outside. Okay, you still have the square outside. And when you expand this, 2 squared times x minus 3 over 2 squared. Okay, indice law. A times b squared equals to a squared times b squared, indice law. A lot of students will forget the square at all, just take the 2 outside, and that's a wrong answer. We need to know this because later on there's a question you need to do this process. So that's minus 4 on 3, x minus 3 over 2 squared. Okay, actually you not get a 2 out, you get a 4 out because of that square. Okay, because of that square, you take a 4 out. So that will be a better form compared to the previous form. Okay, it's a better form because it's the turning point form. Okay, it's the turning point form. Any questions to this? Okay. If you don't have any question, well, that's the type 1 question. Give you the original, give you the word description, and ask you for the resultant function. So we follow in this way to do it. Let's have a look at the next page. Okay, next page. I want you to try the first example by yourself. Okay, give you 3 minutes to try the first equation by yourself, which is exactly the same as what we do yesterday. This is a resultant function and the original function. You compare them and trying to see what's happening. Okay. Okay, for the first one, it says find the sequence of transformation which take this graph to this graph. So this graph is y dash and x dash. Okay, that's the y dash and x dash. So it's already like, you know, it's a square root function and you only have square root on the right hand side. Well, you can treat square root as a house. Okay, so x is the people who live in, and then 5x dash minus 2 is the people who move into the house. So you will equalize both sides. So y equals to y dash, and then x equals to 5x dash minus 2. Okay, those two house, like the people live in, needs to be the same. So you make them the same. You can see there's nothing happening to the y side. Y dash just equals to y. For the x side, I need to make x dash to be the subject because I want to describe things. I want to see, okay, what's happening to the new point compared to the original one. So x dash equals to x plus 2 over 5. All right. This is the important part. This can be further read into 1 of 5x plus 2 over 5. The expand form will be the DRT form. Okay, the expand form will be the DRT form. Well, what mean by expand? This is not in the expand. This is in the factor form. Like 1 on 5 is the factor. Both ways are correct. Okay, both ways are correct. Let's say this is number 1. This is number 2. This is number 2. Okay, number 1, I should describe it like, okay, translate 2 units to the right. and then dilate by a factor of 1/5 from the y-axis. Okay, then by a dilate. So translate first. Okay, first step is translate 2 units to right. Calculation order must be the same as the transformation order. So which you calculate first is x plus 2 by the second last line. So you will say translate 5 units first and then dilate by 1/5 from the x-axis. If you use number 2, you will say, okay, same order as your calculation order. You will calculate 1/5x first. That's a dilate by a factor of 1/5 from the x-axis, y-axis, still y-axis. Then translate 2/5 units to the right. Okay, they both dilate by a factor 1/5, but one is translate 2 units first and then dilate by 1/5. One is dilate by 1/5 and then translate 2/5 units to the right. So that they are the same result. They have the same result, but like the order is important. If you change the order, the translation unit will change. Okay, the translation unit will change. We accept both answer as long as you write in the same order. Okay, you say translation first and then you say dilation, or you say dilation first and then give translation, give the correct units. Well, you can't just say, oh, dilation by factor 1/5 and the translation 2 units is not working. Okay, must follow the correct order and then give the correct dilation and translation units. Okay, that's the first one. If you can see the second one, so this is which make this graph to that graph. So this is the original graph. This is the new graph. So I'll put dash on that. Okay, I only want square root on one side. That's the square root. That's the square root. I only want to leave those two on the right hand side. So I will move everything. Y minus 3 over 2 equals to square root 4 minus x. And y dash minus 6 over negative 1 equals to square root x dash. Okay, now I can equalize both sides. So y minus 3 over 2 equals to y dash minus 6 over minus 1. And we have x 4 minus x equals to x dash. What needs to be the subject? X dash, y dash, okay? Right. X dash, y dash needs to be the subject. We want to describe what's happening to the new point. So, well, it's a bit hard to rearrange that. I will times the negative 1 to the other side. You have minus y plus 3 over 2 equals to y dash minus 6. Okay, times minus 1 on both sides. I put the minus 1 on top, so you have minus y plus 3. Minus a half y plus 3 over 2. And then plus 12 over 2, which is the 6, equals to y dash. I have separated everything. Okay, I don't want to see things like in a fraction form. I want to separate everything because I want to follow the DRT order. Well, it's alright you don't follow that, but I would prefer you can do the DRT order. So expand everything. So what I will have is y dash equals to negative a half y plus 15 over 2. Plus 15 over 2. Then this side is already x dash to be the subject, but I will write in this order. Okay, minus x first and then plus 4, like better than 4 minus x. Okay, if you can see dilation from both sides, there's only dilation for half. Okay, so follow the order. dilation by a factor of half from x-axis because it's changing y. Okay, from x-axis, that's a dilation by a factor of half. From the x-axis, that's where the half from. DRTR reflection, reflect in the x-axis and y-axis. Okay, after I expand it, I can just follow the DRT order because the negative is the next. Okay, both negative. So reflecting x and reflecting y. You don't need to describe y and then x. You can mix them. So you can just mix them. So that's like a reflection from x and from y. And number 3 will be a translation. Translate 4 units to the right and 15/2 units up. Okay, translate 4 units to the right and then 15/2 units up. Alright. That's the order, okay? That's we talk about the order. The order is important, but not necessarily always follow DRT order. But if you also use DRT order, that must be the expand form, okay? In the expand form, or if you make it into like x plus 2/3, you need to describe the translation first, and then it's the dilation. Okay, 2 more questions to go. Have a look at example 3. Let me know what's the difficulty you feel. Like, what's the difficulty? Why you can't, well, hopefully you feel you can't start straight away. Like, why you can't start straight away? What's the problem? There are many x, okay, in the function. Just let you know, when you do transformation, well, it's not really true, but that's like tips for like doing questions. When you do translation and inverse, only need one x and one y in the equation. Okay, when you do translation and inverse, you only need one x and one y in the equation. Okay, there's many x, which is not good because I can't compare like which x compared to which one. Like what is the house? Like what is my rule? Like I can't see my rule. Like I can't follow a particular way of doing that. Inverse is the same because if you have more than one x, when you change the x and y, you have many y in your equation and it's very hard to solve. So I'll prefer the original equation just have one x and one y. So for example, we have 2x and one y in this equation, which is not good. So the question related to this is quadratic and hyperbola. For the quadratic, it will give you the expand form, like the general form, okay, ax squared plus bx plus c. And for the hyperbola, it will give you the ax plus b over cx plus d form. Remember, as I said, linear over linear, that's a hyperbola. So you need to use at a long division or like by looking at it, like make the number work and then put into the what form, like the hyperbola form. So a quick example, 2x plus 1 over x minus 2. I want to make into hyperbola. I need to do long division. Well, long division is 2x plus 1 divided by x minus 2. I have a 2 here. 2x minus 4. I have a 5 left. So this equals to 2 plus 5 over x minus 2. That's back to a hyperbola form. Okay, that's back to a hyperbola form. So I have only one x and one y in this equation. and then I can swap the x and y, do the inverse or do the transformation. It's very hard if you have one equation like 2x plus 1 over x minus 2, and then I said, oh, that's transferred into x minus 3 over x plus 2. What is it? What's the translation? You can't compare. You don't know what's the rule. I can't compare it. But if you can put into a hyperbola form, that's the 1 over something, that form. So I can do it from there. So that's the only two possibility. They can ask you to convert the form first and then do either inverse or transformation. All the other functions, they only have one x and one y. You won't have more than one x or one y. So that's the only two exceptions here, what you can do. You can do long division. Well, I'm not going to show the other method. So hyperbola, you can use long division to make it into the right form, and quadratic is turning point form. Okay, completing square and you make into the turning point form. That's what you need to do before you do inverse and transformation. So the difficulty we have here is we have more than one x, and we don't like more than one x, which is not working well. So therefore, I need to restrict into one x. Turning point form will perfectly do that. It can't be in the x-intercept form because x-intercept form still have 2x. Okay, general form have 2x. So I want turning point form to restrict into 1x and 1y. So give you 2 minutes to complete the square first. Okay, 2 minutes to complete the square. You should be very confident to complete the square. And okay, I will again change the question a little bit. So dilate by a factor of what from the x-axis and translate how many units from the x-axis and how many units from the y-axis. Second one is dilate by a factor of what from the y-axis, translate how many units from the x-axis. Is not changing, it's just the, and how many units it's not really from the x-axis, it should be in which direction of x-axis. I've just write it this way, from the y-axis. You will make it up or right later by yourself. So what's the horizontal movement, what's the vertical movement? So what's the dilation, what's the horizontal, what's the vertical movement? So that's my question. Like the only thing I want to say is, like as I said yesterday, like you can dilate from different axes. So how much you can dilate from the x-axis and how much you can dilate from the y-axis. So you consider that after you have complete the square. I don't think we have enough space. We can use some of the space for the example 4. Example 4 is not that long. If you have done your completing square, you can check your answer with me. I've made x dash y dash already. So which one into which one, the new function and the old function. I'll give you 1 more minute to finish up that. But if you can't complete square for those two, you really need to practice on completing square, okay? Really needs to do completing square. In the calculator, there's a function called completing square. You can do that. It's under the algebra. I think menu number 3, number 4, 5. I can't remember what's the number, but it's in algebra. Okay, and algebra. So menu algebra, and there's completing square. So you can put the function in and complete for you. But that's only happen when you do exam 2. If it's exam 1, you need to know how to do it by hand. I think the problem might be you will forget how to put bracket here, and when you expand it, like you forget to -3, you -1 instead of -3. That's the common mistake here. So same as that side, you have this a quarter here, there's a bracket, so when you expand it, that's a -1, not a minus a quarter. So that might be the problem. Otherwise, I make the number quite easy to deal with, so it's not that hard, shouldn't be that hard. So if we think about the transformation here, okay, so again, my rule here is this. Something squared, that's the rule. As I talked about this yesterday. So bracket square, bracket cubic, bracket quartic, like they are the rule, okay, they are the rule. So that's the house you need to keep on right hand side. So I will write y plus 2 over 3 equals to x minus 1 squared. Y dash plus 1 over 4 equals to bracket x dash plus half squared. So we have y plus 2 over 3 equals to y dash plus 1 over 4. That is x side. We have x minus 1 equals to x dash plus a half. I need x dash y dash to be the subject. So x dash equals to x minus 3 over 2. Well, y side is a bit tricky. What I can do? I can do this first. So 4y plus 8 equals to 3y dash plus 3. Okay, cross multiply them. 4y plus 5 equals to 3y dash. Y dash equals to 4 on 3y plus 5 on 3. Okay, this is the dilation factor 4 over 3 from the x-axis. Okay, 4 on 3 from the x-axis. So, and then minus 3 over 2. So, translate 3 over 2 units. To the left. And 5 over 3 units up. Okay, that's the first. That's the first one. Okay, that's according to this one, what we have. So we complete a square, we leave bracket square on right hand side, everything else to the left hand side, and we want to see what's the dilation factor. That's changing the y value. So that's the dilation factor from the x side, so 4 over 3. And then move up by 5 over 3, move to the left by 3 over 2. Any questions for that one? That's the normal one. I hope everyone can get this. But the complex one will be how I can dilate not from the x-axis, but from the y-axis. Okay, let's have a think about this. If you don't want the dilation factor to change y, which means there shouldn't be any coefficient outside the bracket. Okay, there shouldn't be anything, because if you have something outside the bracket, that thing will move to the left, and then y will get dilated. Okay, that y will get dilation. Therefore, what I need to do is I need to combine the value back into the bracket. Like for example, the 3 needs to back to the bracket. The 4 needs to back to the bracket, because that's changing the x. Okay, if you put the value back into the bracket, you are changing your x value. So we have, okay, let's think about the y dash 1. The y dash 1 is easy. Oh my god, I don't have enough space. Y dash equals to this 4 is a 2 squared. X dash plus a half squared minus 1. Then what you have is 2 times bracket x dash plus a half squared minus 1. Okay, you put the 4 back into square, but you need to square root that and then put back. And remember the bracket. So y dash equals to 2x dash plus 1 squared minus 1. Okay, the 4 disappeared from the front, which means I'm changing my x now. I'm not changing the y value. Okay. So by rearrange it, y dash plus 1 equals to 2x dash plus 1 square. I will leave everything on the side now. Okay, to the x side, to the other equation, y equals to root 3 squared x minus 1 squared minus 2. So y will be root 3 bracket x minus 1 whole thing squared, and then minus 2. Then y is root 3x minus root 3 squared minus 2. Y plus 2 will be root 3x minus root 3, then squared. Okay, this is very complex, I know. But because I want to dilate from the y side, which means the coefficient must be in front of x, not in front of y. So I need to combine the coefficient back into the bracket to make sure that my y hasn't been dilated. Okay, at least see from the equation the y hasn't been stretched at all. Okay, so I will equalize both sides. Y dash plus 1 equals to y plus 2. Y dash equals to y plus 1. Okay, y side is really easy now. Like x side is more complex now. So 2x dash plus 1 equals to root 3x minus root 3. 2x dash equals to root 3x minus bracket root 3 plus 1, yeah. Minus 1 minus root 3 is minus root 3 plus 1. X dash equals to root 3 over 2x minus root 3 plus 1 over 2. That's just a number. You don't need to know how large it is. It's a positive number. So it's a moving to the left. Okay, it's moving to the left. So just combine them together. So now you can see the dilation factor is in front of your x now, not in front of your y. So the dilation factor will be root 3 over 2 from the y-axis. Okay, root 3 over 2 from the y-axis, not from the x-axis now. And then moving, translate root 3 plus 1 over 2 units. To the left. And 1 unit up. Okay, that's just a long question. But the important thing I want to say is here. If you want to dilate from the y-axis, you need to put the coefficient connect to the x. So that's how you can put the value back into a square. I'm going to show you like a couple of questions, previous 2 questions, I think. I can get out the coefficient from the bracket. So that's how I can put it back into the bracket. That's just a reverse step. Okay, how I can get it out and how I can put it back. So when I put it back, there's no coefficient for y, therefore the dilation factor will only apply to from the y-axis, not the x-axis. I know it's quite terrible question, long and no space for the next one, but you should understand that. Okay, this is an actual question I see in one of the paper. I don't know which paper, but I have seen it. Maybe it's the SAC from a couple of years ago, or maybe. I can't remember where I see this, but like, which is important. Any questions? Such a long question. Okay, example 4. Example 4. Find a sequence of transformation for the graph y equals to fx to y equals to 3f1 minus x minus 2. Okay, this I don't need that much space. I'll just find somewhere here. Okay, y equals to fx, y dash plus 2 over 3 equals to f1 minus x dash. Okay, just leave f bracket on right hand side. Anything else to the left. So y dash equals to 3y minus 2. X dash equals to 1 minus x. So x dash is minus x plus 1. Okay. DRT order, dilate by a factor of 3 from the x-axis reflect in the y-axis. This causes changing x. Reflect in the y-axis and translate 1 unit to the right, 2 units down. This one, if you can use the mapping, is really easy to see. Okay, it's really easy to see. It's a little bit hard to read, but this one's not that hard. Okay, all of this page is type 2 question. Give you resultant function and the original function, ask you what is the transformation. So what we want to do is, first of all, we need to distinguish between xy and x dash y dash. And then want to rearrange the equation to make the rule only on the right hand side and any coefficient or movement, translation movement to the left hand side. So then we equalize the y side and the x side. And then we make the x dash y dash to be the subject, because I want to see what's the new point compared to the original one, and then I'll describe it. Okay, so everything just follow the same order. The only difficult thing is like example 3, because it's asked you specifically which axis I want that dilate. So that's a little bit hard to make the form it required. Do we have any questions? No? No? It's all questions, don't know what to ask. Okay, then I will stop here, and next week we'll start